In this section of the NCE Cyber Sandbox tutorials, we're going to be talking about how to create a robust and effective defense system that you can employ in the NCE Cyber Games competition to keep the attackers out of your systems. But before we talk about defense, we actually have to switch our focus and take a look at offense. You might be wondering to yourself, why should I learn offense? Aren't I a defender? I don't need to know how the attackers are getting in. I just need to know how to keep them out. Well, here's why I think it's also important as a defender to learn offense. First of all, if you understand the techniques, tactics, and procedures that our attackers are using against you, you can use those same techniques, tactics, and procedures to find vulnerabilities in your own environment and fix those before the attackers have the chance to use them against you. The second reason why I recommend learning offense as a defender is because everything that an attacker does, every action that they take, creates some sort of indicator of compromise. So when an attacker is probing the network, you can see that in network logs when you're monitoring the network traffic. Or if they're interacting with a service, you can see that in the logs for that particular service. So knowing those indicators of compromise can help you be able to spot attacks as they are happening so that then you can mitigate the damage. The third reason why I believe it's important to learn offense is because the tools that attackers are using have certain limitations. And we can use our knowledge of those limitations to set up defense systems that would make those tools ineffective. This is where I come in. So I'm actually a former competitor in the NCE Cyber Games competition. I was on the Illinois Tech team back in 2022 when we won the NCE Cyber Games nationally. Nowadays, I work as a penetration tester, red teamer, ethical hacker, basically, and I'm also a red team volunteer on the Collegiate Cyber Defense competition. So this means that I understand both the kinds of attacks that the red team is going to be using to get into your machines, and I understand what it's like to be in your position and having to defend against those attacks and how to be successful at doing that. My goal here is to share everything that I know with you so that going into the NCE Cyber Games competition, you have the tools you need to set up an effective defense. Before we actually talk about the steps an attacker would take to compromise your machines, we're first going to talk about where vulnerabilities come from. And I like to organize this into two kind of categories. The first one is attacks on the actual machines or on the technology itself. And the second one is attacks on people. When we're talking about attacks on machines, vulnerabilities can come from 4 different places. First of all, bugs in code. So whenever an application is first created, it's actually written as code by some sort of developer. That developer may either put a mistake in the code, or perhaps they aren't as security conscious. The developer's job, after all, is to develop the application and make it work, not to focus on the security aspect of the application. And sometimes because of that, they can leave holes in the application that attackers can then take advantage of. Oftentimes, there will be other people like threat hunters who find these holes in the application, then they report it publicly or report it to the developers, and the developers have the chance to go back in and fix the code so that it's no longer vulnerable. That's known as patching. So there's this kind of back and forth where developers create code that maybe has a vulnerability. Then there's a threat hunter or somebody who finds that vulnerability and reports it. And then the developers go back in. Then they release a new update where they fix or patch that vulnerability. This is why it's really important to keep your applications up to date, because as time goes on, people are finding more and more vulnerabilities, and developers are issuing patches for those vulnerabilities. One of the best ways to keep applications up to date on a Linux system is to use a package manager like apt-or-yum and ensure that all the packages that you're using are up to date and grabbed directly from the legitimate source repositories associated with that Linux distribution. The second place where vulnerabilities come from is misconfigurations. So maybe the developers wrote good code that doesn't have any holes in it, but then they pass that code or that application that they created over to somebody who's going to actually be using it. I'm calling that person the administrator. Administrators are usually given, along with the application, they're given a set of configurations or things that they can change about the way the application behaves, and they can choose how to set that up when they're actually setting up that application. Now, there may be certain sets of configurations that, if employed by these administrators, allow attackers a way in. So this is kind of the second place where vulnerabilities come from. Then perhaps the developers wrote sound code. Perhaps they gave it to the administrators who configured it in a way that it was very secure. However, there could still be intended features or intended ways the application works that can still be abused. For example, if a web application has to communicate with a database, a lot of the times what that web application has access to depends on the user that's accessing that web application, right? So let's say user John is accessing this web application, and that web application has to reach out to that database as user John. The web application would have to be able to impersonate different users when reaching out to the database. And an attacker who, for example, compromised that web application can now also impersonate different users when reaching out to that database. This is an example of a feature that is intended. It has to be there for it to work, but this can be abused by a malicious actor. The last place where vulnerabilities sometimes come from is backdoors in the software or hardware that is being used. So when we're opening a service such as SSH and exposing it, there are many things that go into the development of that service. First of all, you need the hardware to actually run that, right? Then you have the operating system on which you're running that application. On top of that, you need the packages that that service relies on, and you need the service itself. In any step of this process, if there's some sort of malicious actor or threat actor that has bad intentions, they could backdoor either a package that's required, they could backdoor the hardware. This is another place where vulnerabilities come from. Then, just for the sake of completeness, the other way that attackers attack is focusing on the people. This is commonly referred to as social engineering. I won't be focusing on social engineering in this portion of the NC Cyber Sandbox tutorials because that's not really a part of the competition. In the competition, you are supposed to defend your machines. You're not pretending that there are actual users using those machines, if that makes sense. So now let's talk about the actual stages of an attack, or what does an attack look like? The first stage, reconnaissance, is where the attacker maps out their target and learns more about it. One of the biggest parts of reconnaissance is scanning. So scanning is when the attacker is directly probing the target to learn, for example, what ports are open, what services are exposed on those ports, maybe what versions those services are running on. And this is where, in the real world, attackers would normally spend most of their time. Maybe 75% of the attacker's time is not actually spent attacking. It's spent learning about the system that they're going to attack. Because the more the attacker knows about what's present, the more likely the attacker is to find a vulnerability that they can take advantage of. In a competition like NC Cyber Games, it's quite probable that the red team already had access or knows what your environment is going to look like in advance, so that they can cut down on a lot of time that they would normally have to take in this stage. However, they're going to have to return to it and perform scans when you start implementing changes or when you start implementing defenses, because what they're attacking is constantly evolving. It's constantly changing as you're changing it, and they need to know what that looks like when they're actually attacking it. The next stage, vulnerability identification, is where an attacker takes all that information that they gathered about their target and identifies potential vulnerabilities that they can take advantage of. After they identify those vulnerabilities, it's time to use them. Getting in by making use of a vulnerability and gaining unauthorized access, that whole process is known as exploitation. So the actual attack being carried out, exploitation. The first time the attacker makes it onto your system can also be called initial access. After the attacker gains initial access, a lot of the times they'll gain initial access as a user that doesn't have full privileges over that machine. In Linux, there is one user that has full, complete control over the machine, and that is root. So a lot of the times, an attacker might get in as a service account or as a user that is limited in what they can do. The attacker has to find a way of moving from that user with limited privileges to root, where they have full control over the machine. The process of doing that is called privilege escalation. The way an attacker does that is, once again, by probing the machine. Now that they're on it, they can see what's actually inside that machine, find another vulnerability that they can take advantage of, and use that vulnerability to switch from a user with limited privileges to root. Similar to privilege escalation is lateral movement. So lateral movement just means gaining more access in some way. So this can mean switching from one user to another, or it can mean switching from one machine to another. Perhaps an attacker can't gain root on the machine they're currently on, but they can use that machine as a pivot point to move to other machines in the same network. That's known as lateral movement. So lateral movement and privilege escalation are kind of done in tandem or together in order for an attacker to further compromise the system. Then at the end, when the attacker has gained full control, or even as they're going along, even once they obtain initial access, they'll likely establish persistence. This means placing ways for them to get back in easily next time, or in case they lose access. So there are two primary ways that attackers establish persistence. One is by putting a backdoor on your machine. A backdoor is something that an attacker can later make use of to get back in really easily. So most commonly, this is some sort of file that they can run remotely, or that gets run that would allow them a way back in. The second way that attackers establish persistence or keep control over your machines is through things that run when an event happens. What I mean by that is, for example, cron jobs or systemd services or systemd timers. These all are ways of running a command when a certain event happens. So either when your machine is booted, either on a regular time interval, and attackers can take advantage of that and run malicious code that connects back to them when that event takes place. So, high-level overview, reconnaissance, collecting information about the target. Then you have to identify vulnerabilities. That's vulnerability identification. Then attackers use those vulnerabilities to gain initial access. This process is known as exploitation. From there, attackers use a combination of privilege escalation and lateral movement. Lateral movement just means gaining further access. So it could be switching users. It could be moving to other machines. Privilege escalation is going from limited user privileges to root or full control over that machine. And then in the end, to maintain access, attackers use persistence. Persistence comes kind of in two forms. One is a backdoor that they can later make use of to get back on your machine, or something that runs when a specific event happens. So if your machine gets rebooted, an attacker would normally lose their session on your machine. Perhaps they could use something like a systemd service. We'll get into persistence mechanisms later, but they can use something like a service so that once your machine reboots, it gives them back their access. This is the overall high-level overview of what an attack might look like. Before we can take a closer look at those attacks, I want to really quickly talk about an important concept called command and control. So command and control applies after reconnaissance, vulnerability identification, and initial access, right, after the attacker gains their first foothold on your machine, they need a way of staying on your machine without you detecting them, so that they can do things like privilege escalation and lateral movement. And this is where command and control comes into play. So once an attacker gains access, command and control, also known as C2 or CNC, allows an attacker to stay on your system undetected. How do they actually do this? Well, first let's talk about the goals that command and control has to meet, right? Or the requirements that command and control has to meet. The first one is to disguise malicious traffic as legitimate. The attacker is not actually sitting on your keyboard and doesn't have physical access to your machine. The attacker is sitting elsewhere. They have a machine elsewhere on the network that is connected to your machine. Now, as a defender, a lot of the times you'll be monitoring network traffic so that you can see the connections that are coming from the attacker. And so they need a way of connecting these two machines, the attacking machine and the victim machine, without you as the defender being able to monitor traffic and spot them. So the first way they're going to do that is by disguising malicious traffic as legitimate. And then the second way they're going to do that is by making traffic as infrequent as possible. The reason they do this is because, let's say the traffic looks legitimate, but there's a lot of it. Perhaps your web server is being hit with hundreds of requests at a time. That's going to look a little suspicious to you as a defender as well. So ideally, as an attacker, you also want that communication back and forth between the attacker and victim to be as infrequent as possible. And then how does command and control actually go about accomplishing these goals? Well, bear with me for a moment while I talk about the steps that it takes, and then perhaps after that, we'll talk about the why. So the first thing that you would do for command and control is pick a legitimate protocol on the target. So a protocol that is actually being used by the victim. Some examples of common protocols that are used very frequently in the real world are HTTP or HTTPS, which is used to make web requests, and DNS, which is used to resolve human-readable domain names into machine-readable IP addresses, and it works alongside HTTP and HTTPS. Both of these are used for things like browsing the web or downloading updates. So, if an attacker were to disguise their malicious traffic by using one of these protocols, they would blend in really nicely with legitimate traffic that's actually happening in the victim's environment. So, the next thing the attacker would do is they'd take all of the data that they need to send back and forth between the attacking machine and the victim machine, and they'd wrap it in that protocol. What do I mean by that? Well, they take a legitimate request that uses HTTP or HTTPS or DNS, and they would hide the data in those malicious packets, in those legitimate packets, right? So, for example, they could take an HTTP request to a web page, and maybe in the cookie for that request, they would hide the data that the victim needs to know how to respond to the attacker. Then the last thing, so these first two that we talked about, picking that legitimate protocol and wrapping all the traffic in that protocol, that helps attackers disguise malicious traffic as being legitimate. However, in addition, we need to make traffic as infrequent as possible. So how do attackers accomplish that? Well, the victim and the attacker are only going to communicate every so often. And while they're not communicating, they're going to sleep or do nothing for an extended period of time. This means that the whole process would look like the victim communicates to the attacker, they exchange information, right? The victim maybe does something, and then it does nothing for a while. And then it repeats. So it reaches back out to the attacker, does something, and then does nothing for a while. And by including these sleeps, or these periods of doing nothing between requests, this allows traffic to not happen all the time, but only every so often. And so somebody who's sitting there and monitoring the network is less likely to see a flood of traffic and mark that as potentially suspicious. So you might be wondering, how long does the victim machine actually sleep between requests to the attacking machine? And that really is up to the attacker. There's a trade-off. So the lower the sleep time is, or the less that victim waits between times that it reaches out, the more often the attacker can issue instructions or tell the victim what to do. We call that interactivity. However, conversely, the lower that time is, the more frequent the traffic is. So somebody monitoring the network is more likely to notice that something weird is going on. How does all of this work in the end? So we kind of know generally the goals that command and control is trying to accomplish. We have a general overview of how it's addressing those goals, but how does it actually work? So first of all, the attacker uses some sort of vulnerability to get onto the victim machine, right? Now, once they get onto the victim machine, they can pretty much execute whatever code they want, let's say. They might be limited. They might only be users that don't have full control over the machine, but no matter what, they should be able to do something, execute some kind of code, even with limited privileges on that target. And so they will use that vulnerability to do that, and that will kick off this whole process. So the attacker will send what's known as a payload. That's the actual malicious code that gets run that kicks off this whole process. It's called the payload. They'll send that payload to the victim, and that payload will start this whole command and control process. And what does this command and control process look like? Well, the victim is going to reach out to the attacker and say, I'm ready for instructions. Then the attacker is going to reach back out and say, hey, here are your instructions. The victim's going to run those, and then it's going to sleep or do nothing for a while. Then it's going to, again, reach back out to the attacker, ask for instructions. The attacker's going to give it instructions. It's going to sleep and do nothing for a while. And that process keeps happening over and over until the attacker no longer needs to communicate with the victim. Maybe they've accomplished all their goals, or maybe it's found by a defender and the defender stops this process and kicks the attacker out. One other thing that I want to quickly talk about is in command and control, attackers use reverse connections. What does that mean? Well, whenever the attacking machine and the victim machine are communicating with each other, whenever those requests are happening, the victim always reaches out to the attacker first. Why is this? Well, in a real-world environment, defenders will often put up a firewall between the outside and the victim machine. The way this firewall works is it blocks any traffic that comes to the victim machine that could be potentially malicious. But at the same time, the defender would assume that the victim machine, anything that happens on the victim machine or any outgoing connections are legitimate. So a lot of the times those outgoing connections aren't going to be blocked. In fact, blocking those outgoing connections in the real world might be detrimental to how the machine operates. For example, the machine has to download regular updates. If you're blocking all outgoing traffic over something like HTTPS or DNS, that machine won't be able to download updates. And so that machine needs to have outbound access through the firewall. That's why attackers use reverse connections. Or in other words, whenever this process happens and the victim reaches back out to the attacker, the victim's always going to reach out first and ask for instructions, rather than the attacker reaching out to the victim. As defenders in a competition, even though this might not work very well in the real world, one of the strategies you could use is actually blocking all outbound traffic from your machine, and that kind of breaks this reverse connection. If the victim machine can't reach back out to the attacker because you've used a firewall to block outbound connections as well, then attackers will have a harder time making use of the most common command and control frameworks. This is one example of how understanding the limitations of tools that attackers are using helps you as a defender come up with a defense system against those kinds of attacks, and is one of the reasons why I'm introducing you to command and control in the first place. This process may seem complicated, and how do attackers actually go about picking that legitimate protocol and fitting all the data into that protocol and having the victim sleep? And fortunately, there are frameworks out there that attackers can already make use of to do this for them. So one of the most common ones used out in the real world is Cobalt Strike, although that's a paid framework, though many malicious threat actors are able to find illegal ways of obtaining it for free. In addition, there are some actually free command and control frameworks like Havoc, Mythic, Covenant, Sliver, just to name a few examples. Before we actually go in and I show you how attackers do what they do and how we can defend against it, I just want to bring your attention to this GitHub repository. I will be referencing this repository in future videos. And this is a collection of materials that I put together and made publicly available for any team competing in the NCE Cyber Games. It includes the checklist that Illinois Tech used to win the NCE Cyber Games nationally. It also includes a bunch of other materials related to attacks and also related to working with Linux, like, for example, a command line cheat sheet. So for now, I'm just throwing this link out there. You're welcome to go ahead and check it out. We're going to be digging more deeply into it in future videos.